All right, let's get started on working together on workbook number 2. So this isn't where your book starts off, but this is where we're going to start off. We're starting off with some definitions. And the reason that we're doing this is because I'm going to be using these words, and I don't think it's fair to start using words that people don't have a clear idea of what they mean. So we're going to start off with the word at the top, which is astronomy. So one of the key ideas, and this has come up a couple of times, astronomy is not the same as astrology. So astronomy, red line means that this is a definition. So astronomy is the study of stars and the universe. Astrology is using stars to tell fortunes. So however you feel about astrology, astronomy is a science and astrology is not science. So if you're really into astrology, that's cool. We've got no beef, but I'm just saying this is the name of the class, not that one. Okay. And they seem similar because of that root right in the word. So astro means star. Just like if you ever see like an asterisk, that asterisk means star. So let's get started and figure out what some of these words we're going to be using mean. So let's start off. All of these are going to be definitions, so I'm going to preempt myself and put a red underline. Once again, you don't have to be doing this, but I find it makes me more organized and more comfortable. So let's start off with what is a star? So a star is a massive glowing ball of gas that generates energy via nuclear fusion. Now you might be like, oh my gosh, but now I don't know what nuclear fusion is. We're just getting, this is, you came into the movie, you're like a friend's watching a movie, they're watching something on Netflix, you walk into the room and you sit down next to them and you go, what's going on? And they'll be like, okay, I'm watching Game of Thrones. Well, who's that small guy over there? Well, that's Tyrion Lannister. Okay, well, who's that guy with the sword? Well, that's Jaime. That's Tyrion's brother. That's all we're doing. Is this really? We're not giving the whole backstory. We're not catching you up on every single episode. We're just giving you like a basic idea. So a nuclear reaction, for that basic idea, a nuclear reaction involves adding atoms together, squishing them together, or breaking them apart. As opposed to a chemical reaction, which doesn't change the atoms themselves. But like I said, we're going to spend a lot more time on that later on, so don't stress too much. Just know that it's different from a chemical reaction, and it will actually change what element it is. So a planet is a moderately large object that orbits a star and the light is, and I'm going to say almost all, but really almost all, from reflection. Now, we're going to learn in this class, one of the important ideas in physics we're going to learn is that everything that's above absolute zero, which is everything, is quietly glowing, is releasing parts of the electromagnetic radiation. When someone says you're glowing, you really actually are. but you're not glowing in the visible spectrum. You're releasing tiny, tiny quantities of light in the infrared. And so are planets because they're relatively cold. But that's not why you can see the planet in the sky. That doesn't have anything to do. It's not making its own light. The reason you can see the planet, you can see Mars or Jupiter and that kind of stuff, is because of that reflection. So once again, very basic idea. We just want to make sure that we have straightened out before we start getting deeper into the topic. So moons and satellites. So a satellite, we'll start there. Satellite is any object orbiting another object. And this is a little bit confusing because that's not what we usually use that word satellite for. Okay, so satellites include way more than man-made satellites. In fact, most satellites are not man-made, and because any object orbiting another object is considered a satellite, that means that, for example, a planet like Earth is a satellite of our star, the sun, just like our moon is a satellite of Earth. And then finally, a moon is a satellite orbiting a planet. And these are some definitions. So I want to say this is a definition and this is a definition. So we've got this picture right here. This picture down here is Ganymede. And Ganymede is an object that orbits Jupiter. Okay, so Ganymede orbits the planet Jupiter. Now I'm going to do the Dora the Explorer thing. I want to pause for just a second and see if you understand this as kind of a concept check for you. Complete this sentence. Ganymede is a blank of Jupiter. Would you put satellite? Or Ganymede is a satellite of Jupiter? Would you say that it is a moon of Jupiter? Or would you say it's both a satellite and a moon, or neither a satellite nor a moon of Jupiter? Think about it for just a second. Awesome. So you probably figured it out. That means that Ganymede is both a moon and a satellite of the planet Jupiter. Did you like the Dora the Explorer thing? I did. So let's keep moving forward. An asteroid, these are more definitions. And I know this is not like the most super exciting thing, but I'm going to be using these words. And so having like a little bit of an idea of what these words mean, super helpful. So this is a small, rocky, or metallic object that orbits a star. A comet is a small, icy object that orbits a star. people know from other classes with me, my favorite definition of a comet that's really pretty accurate is dirty space snowball. So it's a little dirty space snowball that's orbiting our sun. So our solar system, a solar system is a star or more than one star if they're orbiting each other. Like we might say a binary star system that has two stars. Bi means two. And all the objects that order and all the objects that orbit it. A nebula is a cloud of dust and gas in space. And it's a very important cloud of dust and gas in space because it plays a role in both the birth of every star and the death of stars like our sun. Like not every star death is going to involve a nebula, but we're going to talk about a lot of star deaths that involve nebulae. Nebulae just being the plural of nebula. Technically you don't say nebulas, just you don't say octopuses. So you say octopi and nebulae. So it's just an English thing. The more you know, all you English majors are probably like, ooh, spelling. So a galaxy is a giant system. Your book likes to say an island. I don't know how I feel about that, but they like to say an island. I'll say that a lot. That consists of millions or billions or sometimes even trillions, but more often millions and billions of stars orbiting a massive center. So this right here, this image right here is an image of a spiral galaxy. This is actually an artist's view of our own spiral galaxy. So this is the Milky Way. That's our galaxy. It is a type of galaxy called the spiral galaxy. It is actually an old, well-developed galaxy. And it orbits a very massive center. It orbits the supermassive black hole. Sagittarius. Sagittarius always has two T's, Chris. Put that in there. Sagittarius, a star. Okay. So you actually say that Sagittarius, you may have seen this in the news talking about Sagittarius. How you say that is Sagittarius, it's got an A, so Sagittarius A, and then the star, the little asterisk at the end is pronounced star. So it's Sagittarius A star, even though it's one of the most inaccurately named things because it's not Sagittarius a star, it's Sagittarius a black hole. So, ha 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 ha. Anyways, I thought it was really funny, but that's why I teach science. So, universe. That's everything. All of it, the whole thing, all of it. That's all matter and energy. So matter is, you might want to say, okay, then what the hell is matter and what the hell is energy? Matter is stuff. I know that's not how your book defines it, but it's stuff, okay? And we know what stuff is. Stuff has mass and stuff takes up space. So that's stuff. And energy is the ability to do things. Once again, not how your book would phrase it, but it's, they would say energy is the ability to do work, which is a very complicated way of thinking about it, but matter is the stuff Energy is the ability for the stuff to be doing the things. So, I like that definition because it's sensical to people who are not astronomers. So, one of the things is scale of the universe. This is actually in a separate video. You can go ahead and view that video now and take some notes. This is on scientific notation. You can, so this is your space to take notes. If you don't want to take notes here, if you don't want to take that break right now, that's totally up to you. This is the first set of questions for this workbook. Questions 1, workbook 2, 5 points. So each one of these is going to be worth a half a point. So these first 5 questions are based on those scientific notation. And you can take some of you are going to be like, Dr. E, I've taken calculus. I don't need this. Take a couple of notes and then you know how to do this. Okay, just humor me on that. Some of you are going to be like, eek, I just finished Math 098. And this is kind of either super new or like I only just barely learned it, which we're starting with 0 in this class, okay? I'm assuming no math, no science, you don't know this stuff. So folks that are science majors, please be patient. Other folks, you're welcome here. So the other group of questions here is for each of the following, answer the question, how many times bigger is blank than blank? Show all work. Now, there's 2 ways to do this. This is so you can start understanding scale. And I'm going to actually do number 1 with you. And there's 2 ways to do each one of these. So we're going to do way 1 over here, and we're going to do way 2 over here. Okay, you don't have to use both. You can pick one of them. You could even do a third way. Just show me your work. You know, I don't know what you learned in grade school, but whatever makes you comfortable. I'm going to make sure I got enough pens for this because I like to color code my math. It makes it more sensical to everybody. Everybody else needs some nice color coding on their math. Color-coded math makes better sense. Okay. Because you know where the numbers came from. So, and you'll see what I mean over here. So, one way to do this, how many times larger is, for example, 1,000 than 10? So to figure this out, you put 1,000 at the top. You have a numerator and then our denominator. And then one way to do this is not the only way to do this. Is we would cancel the zeros. So for example, these 2 zeros cancel like that. And that's equal to, and you just do that until you run out of zeros. So we see that there's 2 left on the top. This is equal to 100 over 1, which is 100. So it is 100 times bigger. Now, this is going to end up with the same answer, but it's a different way of doing it. If you're comfortable with exponents, it is so much faster. But if you're not comfortable with exponents, don't be afraid to use this method over here. So one way to write 1,000 is 10 to the 3. Okay, 10 to the 3 is another way of labeling 1,000. This is the same as 1,000. Okay, that blue does not look so different from this blue. Trust me, they're 2 different blues, but oh well. 10 is equal to 10 to the 1. So that would be equal to 10. So this is one way of writing 10. So I'm setting it up exactly the same way. I'm just writing it differently. This is equal to 10 raised to the 3 minus 1. So when you're doing the subtraction, that numerator one, that exponent in the numerator is that first one over there. And the exponent in the denominator, we bring out our green pen, goes over here. 3 minus 1 is 2. So that is equal to, we'll just write it down here, 10 raised to the 2. Don't worry about that. And that is equal to 100. Okay, so we end up with the same answer either way. You get to pick whichever way you're more comfortable with. Or once again, if there is a third way that you have done it, just write it out. Show me your work. That's the only key. You've got to show work. Show work 4 points. And that goes for all math everywhere, other than like the multiple choice Pearson stuff. Show your work for points. If you don't show me any work on your math, I'm going to assume that it's that you're not doing the math.